The capabilities of the select command that we have already discussed allow us to solve most of the data selection tasks. It is important to determine the requirements for the query results, the list of columns, the source tables, the criteria for filtering the data, and the required subqueries. Let's take a look at the general approach to writing select queries using the following example. The task is to display the top 3 the longest films, title, release year, and duration, released over the past 10 years with a PG-13 rating and higher, and are available in at least 2 DVD rental salons. So where do we start? First, you should decide the tables you need, without taking into account conditions and filters. These tables will always be in the From section of the main query. In our case, it is Films table, since it contains all of the columns we need: the name, the year of release, and the duration. Then we're interested in the filtering criteria. For each of them, you need to determine whether it can be applied to the main table, or whether you need to use subqueries with other tables. Our filters are the release year, rating, and availability in at least 2 salons. The first 2 filters can be applied directly to the films table in the main query, since it can be filtered by release year and by the rating column higher than PG-13. And both of these attributes are in the films table. If we specify the last 10 years filter in the range from 2010 to 2020, the next year this query will no longer be relevant. Therefore, you cannot simply specify a particular year. You should count 10 years from the current date using current date and the extract year function. Thus, we will always get the current year. Since we're interested in the last 10 years, we subtract the expression 10 from current year. Now we will proceed with rating filter. The rating markings are standardized, and films with a rating higher than PG-13 are those with an R and NC-17 rating. Also, a simpler solution could be applied for filtering the rating. Let's add it in the comment. The rating column has a special data type. You can find it in the data types folder. enum is a data type in PostgreSQL that comprises a static, ordered set of values. It is taken into account in both sorting and comparison. When declaring enumeration, each subsequent value is always higher than the previous one. Therefore, a rating higher than PG-13 corresponds to the records PG-13, R, and NC-17. In our query, we will leave the enumeration explicitly. And lastly, we're interested in the availability of DVD rental in at least 2 salons. The films table does not contain information about the availability. This information must be retrieved from another table using a subquery. We should use the inventory table. Please note that we do not need the data for the table itself as a result of the query, so we do not join this table to the films table, but using a subquery. It allows the DBMS to optimize while executing the query. We're interested in the film ID field, since we use if as a filter for the main query, and will also display the number of stores that have these films. Since we're using the aggregating function count, we need to add a group by and filter the result by specifying a limit whether a number of stores having this film is greater than or equal to 2. We cannot use aliases in the group by and having sections. You must use the entire expressions themselves. How does our subquery work? Let's run it separately. This subquery returned us all the movie IDs and the number of salons where we can find them. We have added distinct functions in case there are several copies of the same film in the same salon. Then the results of the main query will be compared with the result of the subquery, and only the necessary films will be selected. So we have already received a list of films with a rating higher than PG-13 over the past 10 years, which are available in at least 2 rental stores. Now we need to display the columns of interest to us and show only the 3 longest films. Once again, we need the movie title, release year, and duration. And now we will display the 3 longest films. To do this, let's sort all the movies in descending order by duration and select only the first 3 rows. As a result, we got the top 3 the longest films released in the last 10 years with an age rating of PG-13 and above, which are available in at least 2 DVD rental shops. Using this example, we have learned how to solve the task step by step. First of all, you need to understand what tables you need to get the result. And it is always better to start solving the problem with the form section. In doing so, it is important to separate filtering from tables which serve as a data source. In our case, the data source is the films table, and inventory table is the filtering table, which is used in the subquery, since its attributes are not needed in the result. If the filtering criteria are complex and require subqueries, the subqueries can be tested separately and then be included in the main query. After the from selection, where all tables and their joins are listed, you can proceed to the where section. You need to determine each filtering criteria separately and then filter by them. All filters must be connected with each other using AND or operators. After the where clause, you can proceed to the main selection, specifying the necessary columns from the joined tables, calculating any values. After that, if necessary, add group by, having clause for filtering aggregated values and sorting. Remember that your query must be clear and performant.